Okay, so you want to find the Maclaurin series about x is equal, well, Taylor series about x is equal to 0, c is equal to 0 basically. Um, that will converge to this function for certain values of x, right? So we're going to use this form. We're going to use the form, since we're talking about x is equal to 0, the Maclaurin series, we're going to use this form, right? And that's going to be the kth derivative at x is equal to 0 divided by k factorial multiplied by x to the kth power, right? So that's going to be the form. So in order for you to use that, successfully, you have to find a couple of derivatives. So the first derivative of the given function is going to be 2e to the 2x. The second derivative is going to be 4e to the 2x, right? Because 2 will always come down and multiply the previously existent coefficient, right? The third derivative is going to be 8e to the 2x, and so on. And the fourth derivative is going to be 16e to the 2x, right? So you see the pattern that the coefficient increases by a factor of 2, right? So now we can build this, just a couple of terms to see what the pattern is to successfully find the Maclaurin series, right? So we're going to have function at 0, at x is equal to 0, multiplied by x to the 0 divided by 0 factorial, plus the first derivative at 0 multiplied by x to the first power divided by 1 factorial, plus the second derivative at 0 multiplied by x squared now divided by 2 factorial, plus the third derivative at 0 multiplied by x to the third divided by 3 factorial, and finally that will be enough, the fourth derivative at 0 multiplied by x to the fourth divided by 4 factorial, etc., etc. And then that can be expressed, well, we have to find what this is, right? F of 0 is e to the 0, right? X is 0. E to the 0 is 1. Everything is 1. 0 factorial is 1. X to the 0, since x is non-zero, x to the 0 power is also 1, right? So it's just 1. Plus, let's see, the first derivative at 0. E to the 0 is 1 times 2 is 2. 2x, right? Well, let's write 0 factorial because we're going to need it, right? 1 factorial here, right, for the second term. The next one is what? The second derivative of 0 is 1 times 4, right? So that's 4, now x squared, divided by 2 factorial, plus 8, right? X to the third, 3 factorial. You already can see the pattern. 16x to the fourth divided by 4 factorial, right? Etc., etc. So what does that mean? That's going to give us, that's going to be actually easier than the previous example we've done. So let's see. So if we take care of the factorial, it's just going to be k as before, k factorial, that is, right? Because there seems to be integers involved, right? We're not skipping any numbers. We're going exactly integer by integer, increments of 1, right? Increase 0, 1, 2 factorial, 3, 4, etc., right? So k satisfies that, right? Let me write that a little neater, like that. Okay, so k factorial satisfies the denominator. Now the x, we're going to write it here. X increases also by 1, just like the factorials do, right? So x to the k satisfies that as well. Now, what about the powers of 2? Now, there are no alternating signs, right? Everything is a plus, so we don't need the negative 1 raised to a certain k power. All we need is 2, because that's a factor, right? We discovered that we have factors of 2 all the time, right? Each coefficient increases by a factor of 2. So 2 must be raised to a certain power. When k is equal to 0, 2 becomes 1, right? So it's sufficient to just raise 2 to the power of k, right? Because each time, for each term, the coefficient increases by a factor of 2, right? So 1, k is equal to 0, so that's 1. 2 to the first power when k is equal to 1, right? 4 when k is equal to 2, we'll get 2 squared, that's 4, right? So that's good. So we just found it. We just found the Maclaurin series about x is equal to 0. So now let's find the interval of convergence for this Maclaurin series, right? The interval in which this Maclaurin series converges to the given function e to the 2x. Okay, so we're going to use the ratio test, right? The ratio of one term of the sequence divided by the previous term of the sequence, and finding the absolute value and then the limit of that absolute value, right? So let's see, that's the ratio test. Okay, so what are we going to have? We're going to have 2 to the power of k plus 1 times x to the power of k plus 1, right? We're replacing k with k plus 1, right, for this term, divided by k plus 1 factorial, and then we're going to instead multiply rather than divide because we're dealing with a fraction. We're going to flip these guys around. K factorial goes on the top, and 2k to the xk goes on the bottom. 2k to the xk times xk, x to the k goes in the denominator. Right, so let's see what that gives us. So 2k will go away. 2 to the first power will remain, right? X to the k will go away. X to the first power will remain. K factorial goes away. K factorial goes away here, but k plus 1 will be factored out, right? So basically we will have 2 divided by k plus 1, right? Because k plus 1 factorial can be expressed as k factorial times k plus 1. K factorial will cancel out with the top, so k plus 1 remains. So that gives us 2 and then absolute value x, right? Because x must be still in the absolute value because x can be negative, right? We said about x is equal to 0, which means around x is equal to 0, right? So x will go in the negative direction as well, right? So we need to put the absolute value in there. So now what does that mean? It means that we have two possibilities. So the limit will be 0 if x is equal to 0. Right? So if x is equal to 0, the limit value will be 0. And what if x is non-zero? If x is non-zero, the numerator will be non-zero. However, if you take the limit, right, using the kth term for divergence, well, just finding the limit, you don't have to use the kth term, but just finding the limit, plug the infinity in the k here, you will get non-zero divided by the infinity, which is equal to 0. Right? So you get 0 either way, if x is not equal to 0 or if x is equal to 0, right? So converges, right, converges for all x. So that means that the interval of convergence is from negative infinity to positive infinity, right? Basically all x. Thank you so much for watching, and I'll see you in the next video.